it's a little flooded. This is the world as I've known it, as many of us have known it for owning FD RX-7s. Boost comes in, and then there is a throttle body with a couple different blades inside of here that open up and provide us boost to the rest of the engine. On a rotary engine, this very unique thing, I think at least the way it's set up, is that the bottom blade down here is meant for the primary low-speed air inlet, and then these top two go to the same upper area, and that's called the secondary. That is how this car has worked for many years, and there's a mechanical cable running over from your pedal to this. We are in the era of computers and electric cars, and we need to get smart with the times. So let's take a look at this and how we're going to upgrade this. First step is yet again another General Motors part. Can't fight what works. This does come off of an LS, but screw the rest of the engine. This is a drive-by-wire throttle body. The most important part is that it is electrical. It's a motor that allows it to choose a point in 0 to 100%. 100% on this, basically minimal interference going through that tube right there, and then 0 would be something like that, completely being cut off. Goal is to replace this mechanical setup with this digital setup. A couple things you have to keep in mind. There is a sensor on this that measures the position. This is called a TPS sensor, and that sensor is trying to replicate this by saying, hey, the throttle is at 0 to 100%. That is the job of that thing is. This, of course, has that as well. There is the same sensor inside of this saying, hey, 0 to 100%. One of the wires in here is certainly going to tell us the position of the throttle. Everything else, though, is controlling it opened and closed. That's cool and all, but we also have to take into account that doesn't plug into any of this. This has to go in somewhere here and then bolt into this shape here. Thankfully, my friends at Full Function Engineering made this. FFE makes a throttle body adapter that goes from Mazda to single blade GM. That plugs in right there, and away we go. Many different ways to solve this side, but since it is boosted, I wanted to fit with the Greddy elbow. Many of you saw this on Instagram as well. I'm saving you guys a lot of time here. I made an adapter from that side to this side, which will then be welded together. But before you weld it, we gotta do some work to it, and I wanna show you what is inside of a drive-by-wire throttle body. If we're gonna weld it, can't have heat on all the electronics. We're gonna take it apart. One very fascinating thing is that the electronic wastegates and drive-by-wire motors are very similar in operation. They're both doing something to open and close, and you have two major power lines going to open and close the motor. My alternative solution to all this is to actually adapt all of this stuff to this here. So if for some reason this single blade wasn't doing the sort of response I wanted, I'm actually going to take this, machine something like this, and adapt this whole assembly over to this assembly right here. If I control this, that's the same as the movement like that. That's in case shit hits the fan and I don't like this single blade. This is bulky, especially on a RX-7, but I don't think there's much wasted space. Make sure nothing bad happens. That's really easy. It spins a lot. The amount of force used to open and close this is quite a bit for an electric motor. So what they do is they basically gear it down. Small gear to this big gear, small gear on the back side of this, I'm sure, yep, to this bigger gear here, and now you've got torque reduction. You have to just move more to move that blade. That's all just gearing, and then over here, the little motor built into there. That is very straightforward, not much to it. That is where the throttle position sensor is, right inside of here. You don't only get a motor, you also get throttle position. So now we can weld onto this one. I'm gonna machine this lip off. My piece is gonna go something like this. And I've accommodated for the way this elbow curves at more than a 90-degree angle, and made sure I gave enough space for that. I tried to port match and flow all that, but I'm learning a lot with machining. See that smooth surface right there? That's a small tool that's only 3/4 of an inch tall, and then that's where it gets rough. So I'll port this out by hand. This took about 3 hours of work. I'm gonna go ahead and work on milling this lip down. Isaiah's gonna weld it up. You know what's really awesome? I just took a picture of my hair last night after the last 3 years of using Keeps. And I'll tell you what, it is actually pretty effective. I have used their service long before I was ever partnered with them to do the videos you see here. If you're somebody like me who is the majority, 2 out of every 3 men by the age of 35 do end up experiencing male pattern hair loss, I sought them out because of how well it works. The whole process is wonderful. They're all hair loss prevention techniques that work. It's no gimmicks, no weirdness, no uncertainty. You can go to the website and figure out all the different options options you have for preventing hair loss. And that's why the name is so fun to say. Keeps, you're keeping the hair you have. You know, with all these crazy late nights and weird cool projects I haven't announced yet, you can see how much I'm pushing myself, and I'm surprised, honestly, that this hair is hung in there. Well, I guess I can't be that surprised because there is science behind why it is. If you're interested in learning more about Keeps, go to keeps.com/RobDahm to learn more. It's KEEPS.com/RobDahm. Simply try to cut that lip off. Let's hope for the best. I left the slightest bit of a lip there, so that way I could do it twice. That took it right off. Things become super easy. Oh, baby kitty, what are you doing over there? What'd you say? Really? Aw. Do you want more pets? Is that what you're looking for? So let's see how much that lines up with this. It shouldn't fit because I purposely gave it some more room, but right on the edge. I can take those extra couple thousandths off and this will fit. I'll skip right to that. After that second pass, look at that press fit. That's on there. It's not all the way down because there's still a test run height-wise, but we'll weld the inside of this and then burr it all out. But that's super exciting. And we now have boost-ready throttle body. Just simply press fitting them together. If we were getting real particular, I would actually grind my side down. This is a very thick piece. We could grind that down and get it to fit even more flush, but Isaiah could just work his magic from here. I gave him extra material so he can weld it in.
Oh, yeah. I'll just air it out. There's a decent amount of meat in there, so I'll be able to pull that towards this a lot.
With the wiring harness about 95% done, I'm just waiting on one connector for this right here. It is taking shape. It is beautiful. Everything is all sealed off. And if you want to check out how I built this, go back to the wiring harness video that was done just previously. That said, I can't wait, and I want to test the drive-by-wire. I've got all the drive-by-wire set up connected. Here's the throttle right here. And then on this end, inside of the car, and I made a small little harness with the pedal. It's cool to show you that, but let me show you what they actually connect. Over here is my custom-made drive-by-wire throttle body that connects up to the ready elbow. Sure enough, there's the 6-pin connector on that end. And then, oddly enough, this is actually out of the CTSV, so the CTSV comes back to haunt me. But this is about an $80 drive-by-wire pedal, and all it is doing is powering 2 sensors in there, and both sensors are relaying how much I've moved this. That is a very small amount, but that's all you need. Very standard GM product, AC Delco, whoever actually makes it. Our goal is to get this pedal to move and adjust this brass throttle body directly and accordingly. So if I'm gonna do 40% throttle to pull a wheelie at a drag strip, where is that? The ECU will know. We're gonna go ahead and use a shit car. This is what's nice about cheap plastic, is that you have tons of workspace. We are going to power up this harness with the Fuel Tech 600, which we have not fired up yet, and hopefully I do not blow this up doing this. But first, we've got this little harness here, and so there's my 12 volts in. This is normally inside the car, and we are going to put that onto here. I'm really just using the RX-8 as a battery. So this thing right now is dangerously charged. We're gonna go ahead and plug this into this end, and that will then charge up anything that is 12 volts inside of the rest of the harness, which if this blows up, well, that's a perfect test right now. Second side of the circuit though, is right here. And if I have any really bad wiring, we're about to find it very quickly. There's no circuit. The ECU is not connected. All these sensors should not be shorted out or doing anything weird. Life, as we know it, is good. Now we will plug in the pedal and then the throttle itself. Here comes the scary part. I hope Anderson from Fuel Tech doesn't watch me do it this way, but I'm going to plug in the ECU. Now this could fry the computer if there's something wired incorrectly. There we are. Oh, that is beautiful. So there you go. There's a first fire up of the FT600 for us. While this is Isaiah's wet dream of setting up a Fuel Tech on his RX-8, it is literally just being used as a battery. We're gonna go ahead and plug this in. You can run the configuration wizard from here. I did that with the FT550. We're gonna do now, test one of Fuel Tech's claims, which is I have a map from a 550. I'm going to just simply put it onto this one and see if it fires up. The car did not have drive-by-wire before. What we're gonna do is we're going to go under pedal and throttle here, and it currently has TPS. We're gonna switch this over to a single throttle. 169, nice. 88 millimeter Corvette V8, there. I just recognized that number too. With that enabled, we now have this aware of the throttle, but here's the thing. I went through and mapped which sensors are what. This pin is this pin's this. Have to go through and do this if you're making a custom harness. This isn't the output it was before. Go to the wiring harness here, which is this here, and we know that drive-by-wire is pins 26 and 27. It's the fans. What we're gonna do is we're gonna tell 26 and 27 to get their shit together and say, hey, you're actually drive-by-wire. I took a quick breather and figured something new out. Remember, there are two sensors inside of the pedal, not the throttle. Even though this is a throttle-related thing, this is a pedal, and it's named appropriately, pedal 1 and 2. This throttle has throttle 1 and 2. So when I did my inputs, I did it wrong, and I said throttle 1 and 2, and those were pedal 1 and 2. And then down here is throttle 1 and 2, or A and B. The cool part is, I did all that, set it all up, and it still didn't work. I then went and simply did what Fuel Tech wants you to do. Up here, I'm going to calibrate TPS ignition, and it got way closer to this than I did. Calibrate this for 0, press this pedal all the way down. They do give different voltages, by the way. And then calibrate this for 100%, and then go ahead and click save. And then all of a sudden, the monster comes to life. So you're going to hear a little bit of whining coming from this. That is normal. That's what it does. It's holding the throttle shut. I am not going to put my fingers in there. I don't feel like losing them. But watch this.
Whoa.
That is really impressive.
Pretty responsive too.
Yeah. You can control how much pedal means how much throttle. All of that can be controlled. That speaks for itself. What's really nice is that we can now have it where it says, hey, you know what? The car needs to idle better. It'll fuck with the idling like this without your pedal moving at all. We now have drive-by-wire pedal. A lot of complicated, insane extra pieces needed, but the benefit is pretty obvious. Idle air control, cruise control, launch control, all of the above, all with a simple replacement of one single cable. The drive-by-wire works. What's different about this harness compared to what is on the 3-rotor already? It's gonna kind of blow your mind. I made this harness what I thought was the best of my ability, and I still came up short. This harness has these pressure sensors, and because I didn't have or understand what those connectors were, I crimped the ones in from my older cars. That's all exposed, it's all crimped. It's nice, but it's all just sitting out like that. It's gross. Same thing with my oil pressure sensor. You can see exposed jackets, and that's oil getting all in there. All of these are all using just 3Ms type of heat shrink, and you can see it already, it's just getting rough. Yet again, exposed wire, oil's just getting into all of that. I'm pretty happy with a lot of this, but it just starts to fall apart. Here's my crank angle sensor, and I don't know how it's been running like this, but it's passing straight through both the coils and the spark plugs. That's why you want it shielded. I don't know, I would never do this, so I don't know how it ended up like that. I tried doing jacketed things, did not work. My injectors, this is what I hate. Watch this. I'm gonna go ahead and try and pull this. You can't easily, especially if it's under there and you're turning the manifolds in the way, you have to sometimes pull on this to pull these off. And this is pretty standard. This is how it is. But if you aren't grabbing onto here, you are literally grabbing onto the crimped wires to pull that back. That is my biggest pet peeve, and we have that no more. We really are just gonna clean up all these extra wires that are coming through here because we weren't sure exactly what this car needed. So this is actually gonna get much simpler and much smaller. We'll see a lot of this disappear. Well, there you have it. There is the final harness. We've got ignition, all the rest inside the car stuff, the actual ECU, strain gauge shifter, CAN bus, and then our beautiful assortment of all the connectors that are now oil-proofed away from the wires and whatever else E85 is going to be in this thing. So the last one I did, that just for those with sharp eyes, that's the holy grail. That is the crank angle sensor, and I've glued it, screwed it, nailed it. But I have the whole thing pretty solid. This is a polarity situation, so I purposely have it where I can repin them here, but your crank angle sensor, it'll either read up or down depending on when it sees a tooth, and that matters very much to your ECU, so keep that in mind, is that either you might have to repin it here or there, or if it's part of sensor ground, you just have to be aware that that is a situation that will occur, and that'll mess you up. We're gonna start threading all of these through and get the ECU to now fire up with the car. See how much is actually plug and play. So far it's all been plug and play, but I've got a couple connectors that I've changed. just got here. Always, he just feels it, knows when to show up. It is time to test.
Oh, that's
He thought I was firing up the camera for him.
And it's the same connectors, right?
Different, same but different. You can't swap them over. Here we go for first car power on test. We'll watch the throttle first. Mm-hmm.
All the way.
All the way. There we are. We've got a lot more things to do. The car is now powered on. In theory, I could turn it over and start it, but I have to set up which connections are what now. But I have so many more sensors. Like for example, we just added this guy in. I hate blue connectors on this thing, but we have a flex fuel sensor on the car now. So we can tell both fuel content, ethanol content. That way we can go on road trips and even have to use pump gas if we have to, but it also tells the fuel temperature. So we have that as well as a couple other sensors we have to add to the car. So much better. So look at these injectors. I made them a little bit long on accident, but not a single exposed wire, and they're all just right there. Pop them in like this, safely. It's so clean. So there's not a single exposed wire for all the good stuff. Stuff like this was a test. This is actually gonna get all cleaned up as well. So just gonna kind of keep combing backwards. There we go, we got all the main sensors working. The car, like I said, we'll fire it up in this video. We get to gut all of the older Mazda stuff. I mean, it worked really well, but there's the stock TPS sensor, and then there's one other control valve, but then there's another electrical one. We're gonna go ahead and take this off. I worked really hard to flatten all of this out. Take that off. So with this, we're now able to put the full function adapter on, and that gets us one step closer to, sadly, General Motors' beautiful throttle. So we now have that on this. You'll see there's the beautiful little sensor I welded in, an 1/8 inch MPT. It used to be much larger, and I didn't have the sensor for it. We're gonna take this over to the car. Normally, I try starting the car with the turbo cap on, but this time I'd probably try starting it with these in here. I don't know what would happen. There's the wire for the sensor I just welded in. So here comes the beautiful part. This should connect into here. One of the downsides to welding this onto here, and I knew this early on, was that we will not easily be able to get to this bolt. Thankfully, that's only a one-time thing. I really wanted to machine all the way back to here, but I was like, there's no way I'll be able to slide this bolt into here to begin with. I do not have a gasket here, and that is an issue because that is behind the throttle body. If it's in front, to be honest, you can have a little bit of a boost leak. That's not metered air. That's not air that the car really cares about. Unless it has a mass airflow sensor, that's a little different. Anything behind the throttle body is now being governed by the pressure of the manifold. So up until that point, it doesn't really matter. In this case, this does. We're still in testing, so I'm not getting too worried about that. The whole point of making that adapter was so that way I could use my iconic ready elbow right here. This should just connect in right there. That is pretty sexy looking. We've got almost every sensor working. We're gonna go ahead and try and start it, and it is flooded all to hell just from us testing every single injector and everything. But this is my pedal. I keep wanting to press the pedal down there, but we can't do that yet. So we're turning it on. That's still working. Gonna be pissy because it is just flooded. We just did this, but I want to show you, it's a little flooded. That's fuel. So we just cleared it out, put the plugs back in. As you can see below me, there has been adventure. A lot of adventure. The truck, again, has helped us out. The battery's dead, I couldn't wait. We finally got it fired up, and we had some bugs to work through, but you can hear the car's warm. I'll fire it up for you. But what a pain in the ass. Do not start with drive-by-wire. This is such an extra level of unnecessary diagnostics. That says a lot. I have to say, drive-by-wire kicked my ass, but we made it our little bitch. I got a lot of learning to do, especially how to idle it. It goes up and down a little bit. as you can see right there, there's a lot of learning involved. We had to mess with the approximate amount of idle RPM, but that doesn't even matter because I had to turn idle control on, but then idle aggressiveness. There's a lot of options involved with drive-by-wire, and they are not easy. The hard part I was having earlier is just the car was flooded and the battery was dead, so it was just throwing off everything. So far, I have not tuned the fuel map whatsoever, but we're gonna get the pedal working next to make sure that I can see is the engine more responsive, less responsive, because remember, I went from 3 individual throttle blades to just 1 big one. So I'm super curious to see, did I lose that whole primary, secondary thing that I've believed in for all these years? Could I just be like the 4-rotor and just 1 single runner for all of them? We'll see. The data will show us itself, especially at that low RPM. But right now, it seems pretty damn responsive. That's pretty cool. At least the car idles. It hunts. And you can watch the drive-by-wires like, yes, open, close. Oh. You can see it's worrying about all the problems I don't have to worry about. But it's going to take some fine-tuning to get that. The car will idle very low, even now. With both the primaries and the secondary runners open, it'll still idle very low. It doesn't want to. The drive-by-wire is trying to compensate constantly. Whereas if I idle at about 1700, you hear it hunting a little bit more stable. Isn't that crazy? But with this pedal working, that means one thing. We have to mount it. Surprisingly, after taking out the dash really quick, it's not as messy as you think. I did use this wire in a different car at one point, so we'll cut all the excess out because that's just asking for magnetism. Everything's pretty damn clean. This was actually mounted up here along where the stock harness goes. We'll put it back up there. None of it's woven through the dash, so that's pretty nice. A couple problems I see already. For those of you guys that aren't that familiar with this will not bolt up to the stock pattern on it. Don't even hope or dream. Second thing is that you can see that they're offset from this plate, so we're inevitably going to be making spacers of some sort. Next issue is that I actually am afraid that the pedal sits so close to the firewall and this is such a vertical piece here that the other one kind of has a swing arm. We're gonna have to mount this even further out. That means that the spacers could cause this to wobble. We do not want this falling off or even thinking about falling off. So I'm gonna make sure that however we secure it to the car, it's gonna be probably bolted with Nylox and red Loctite. I don't wanna question if the pedal is like, oh, maybe you're gonna pull out of the firewall because you slam on the gas or something like that. To show you the issue number 3 or so that I was looking at, here's the stock pedal down here. The pedal there is already by default behind the brake pedals, and that's because normally when you're jumping between the two, you have the brakes halfway pressed. This new pedal already is gonna have to go way up there. It's gonna be some serious work. I'm gonna work off camera on making these 3 holes, lining them up, getting them in the right spot, and then working at how far in and out the pedal needs to be. But that's really just gonna come down to hole position and spacers, so you're not missing out on much. So those are studs that we will not be able to use. We no longer need any of that stuff. Now I think that moves more. Oh yeah. I mean, maybe the travel of the pedal. This one's longer. Yeah, this is gonna have to go like out here.
I don't think it fits.
No, it's definitely an OEM upgrade. It's gonna have to sit like right there. What we can do is get the height right, the position right, and then drill the holes and then figure out the depth. What I'm doing right now is taking what are called couplers. They're meant to join 2 bolts or something like this together. I bought tons of all thread. This is 1/4 inch by 20 threads per inch, and I'm actually using these as beefy spacers. The reason why I wanted them to be beefy spacers is that the pedal is going to be resting on these edges, and I don't want things wobbling. So to really minimize this sort of wobbling that I'm afraid of, I went and got flanged nuts. So now the physics is on our side, and the pedal sitting right here has more of a surface area to hold on to. Same thing on this side right here. Now the car chassis is not to be trusted with, to be honest. I would tack all this together once we know the exact lengths, but this is a great way of saying, you know what, is that far enough for the pedal? If not, we can add more of these or cut one of them in half, tighten it all together, and then now we have a decently thick pedal stand. Weird, but it works. And like I said, I'm gonna try it on right here, just a 1/4 inch hole. This is very, very difficult with it being whatever, 105 million degree weather. We got these 2 in, and of course this is not safe to drive it this way, but the third one will actually make a bracket that we bolt off of brake booster bolts here. So it'll kind of do like a C shape. It'll allow us to make this way more rigid, and I think the triangulation will make it huge. But you see all the small, thinner pieces of metal, there's just no way to make that more rigid. My stands actually are perfect length. It'd be kind of hard for you guys to see, but the pedal is far enough over to kind of space it equally with the others, but it does not hit even the hump where Isaiah beat it back a little bit. It gets about a half inch away from that, even at max tilt. The cool part is when you're doing this, you're just kind of trying to make sure your pad of your foot, so behind your toes, is kind of right in this area. I'm sure there's racing professionals that know more about this, but it feels right. It feels like it's actually in the very stock position. I'm gonna make this little bracket really fancy. I'm not trying to brag. Probably the most beautiful thing I've ever made. My mom would hang it up on the wall if she could. Put that in there and then pushing the pedal back up. Wow, that line's right up. We've got a triangulated pedal. Should be able to just kind of screw this on. That is.
Seems solid.
Yeah. I mean, it wiggles as much as, you know, the existing pedals do. Gas pedal.
It's a brake.
Yeah, sorry. That's a gas pedal for the brakes. I don't know, some people call it that. No, so you don't do that. Clutch, brake, gas pedal. I can't feel that movement, to be honest. You know that how you can see it shift just a little bit. I can't feel that, but it'd be nice if there's a fourth bolt down there to support that. But I mean, I'm trying to beat on it. I'm more on the left side of the pedal, so I could have moved it over a little bit. But as soon as I'm off the brake pedal, I'm hitting almost the center of my shoes on that, so we're good. And it is a pretty solid pedal.